Hello, welcome to my YouTube channel. This is Brains Tutor and we'll be dealing with statistics today. And under statistics, we'll be talking on probability. So before we go on solving questions, I want us to discuss what we mean by probability. By the way, in this class, we'll be treating experimental probability. You can check my remaining videos for theoretical probability, combined probability, and tree diagram where we'll be checking on conditional probability. So for today, we'll be treating experimental probability. So before we go on solving questions, as I said earlier, so I want us to know the meaning of probability. And probability is simply the chance or likelihood of an event occurring. So experimental probability is usually based on past events, experiments, or statistical record. And experimental probability can be given with this formula right here, that is number of required outcomes to total number of outcomes, and we can shorten it to this form. Now, number of S is the event that is happening, and that is our sample space, and E is the total number of sample space. Our S can represent number of sample space, that is the event that is happening in a sample space, to the total number of events of that sample space. Now, if we take some example, let's look at the first example here. Example 1 says a fair die is rolled 150 times. The table below shows the outcome obtained. Now, before we can go on to solving this question, let us analyze this question we have, and it's been simplified for us here with this table. Now we can see that the number on die varies from 1 to 6, that is 1 2 3 4 5 6. So if a fair die is rolled 150 times, we want to know how many times 1 will occur. They've already given us that the number of times 1 occurred is 15 times, the number of 2 1 occurred is 20 times, 3 35 times, to 6 which occurred 32 times. So the first question here is to find the experimental probability of obtaining a 2, a 5, and a 6. And from the initial slide, we can see that the number of sample spaces, the probability of a sample space is the number of sample space to the total number of events of that sample space. So the probability of obtaining a 2 is simply number of times 2 occurred, which is 20 times, to the total number of times in which this experiment was performed, which was 150. And that is what we have here. So probability of obtaining a 2 is simply the number of times 2 occurred to the total number of times the experiment was performed. And when you break it down, you get 0.133. So we get the second question, we get what's probability of obtaining a 5? The same way we solved the first one, that is number of times 5 occurred, which is 30 times, to the total number of times the experiment was performed, which is 150 times. So I will get it to be 0.2. The same way of doing obtaining a 6, number of times 6 occurred, and if you check the table, you will see 6 occurred 32 times. So 32 over 150. So you get 0.213. Hello, trust you've been enjoying the video and you have been learning. So I want to use this opportunity to invite you to my private tutoring, which takes place on Zoom online. And I basically teach physics, chemistry, and mathematics. You can check more information on the flyer which is shown on this post, and feel free to message me on WhatsApp. My WhatsApp contact is there, and you can also email me for more details. Thank you very much. See you later. So going on, we'll be going to example 2. So example 2 says, from a statistical research conducted, it was found out that in every 1,000 people, 600 people are female. What is the probability of picking a man if selected at random? So let's go on to solving this question. So From what we've done, we know that experimental probability is the number of required outcomes, the total number of outcomes. So the question says, what is probability of picking a man? But from the question, we're only given number of women, which was 600. So we can calculate the number of men, which will subtract number of women from the total number, and we'll get number of men to be 400. So the probability of me picking a man is the number of men to the total number of people. And when we break it down, we get it to be 2/5. So this is a classwork for us to test our knowledge on experimental probability. And trust me, if you are able to solve these two questions, your knowledge on experimental probability is very good enough. Now, in my next video, we'll be discussing on theoretical probability, which is more detailed than experimental probability, because theoretical probability is based on a test. It's based on what has already been proven, so it is more probable than experimental probability. So you can check my video, you will see theoretical probability. To advance your knowledge, I will advise you watch the video, and there will also be classwork and what you can use to test your knowledge on theoretical probability. You can also check my videos for combined probability. You can subscribe to my channel and like this video. Let me know in your comments how you feel about this video, so I can likewise bring out the best, so you can also learn better. Alright, so I'll give you 5 seconds. You can pause this video. I'll give you 5 seconds. So or you can pause this video, try your best. In the next slide, I'll be posting the answer. So let me give you 5 seconds. Alright, so this is the solution to the classwork. So we can see that the probability of men having a head, a coin is tossed 200 times. A coin only has head and tail, so even if it's tossed 1000 times, the probability of me having a head still remains 1/2. So also the probability of me having a tail remains 1/2. So this second question says, in every 500 television sets, 50 develop faults in the first 3 months of usage. So if I want to pick a TV set, what is the probability that it doesn't develop faults if selected at random? So you can see that this question is actually based on experiments or statistical record. So this is a good question on experimental probability. So the question says, what is the probability of the person picking the one that doesn't develop faults? So the first thing is to find the number of the TV set that doesn't develop faults, which is 50 minus, you subtract it from 500, which is, so 450 is expected not to develop fault in every 500. So you can find the ratio and you get your answer to be 0.9. So thank you very much. Hope you like this video. I want to see your comments below, and subscribe to my channel so you can see more interesting and valuable videos that will help you in your academics.